Hi everyone, so this is the second lesson on energy, and in this lesson I'm going to teach you a couple of formulae related to energy, and so that we can do some calculations on energy. So this topic is some energy calculations. Okay, now the first thing we need to know is what is the symbol that we use to represent energy. So you know that in physics, for every physical quantity there is a letter that we use to represent that quantity, and that letter is called the symbol. Okay, so energy is represented by the letter E. Okay, and the unit for energy is joules. Now, because there's so many forms of energy, we need to actually distinguish, like, so how do we represent gravitational potential energy, and how is that different from kinetic energy, and so on. So scientists are very clever. They've come up with using subscripts. So gravitational potential energy is represented by the letter E for energy and P for potential. Okay, it doesn't really tell you which sort of potential, but if you look at the formula, you will know it's gravitational potential energy. Now, the formula for gravitational potential energy depends on a few things. What do you think it might be? So if you're lifting something up, the thing has got mass, right? Okay, so mass is important for gravitational potential energy. So there's mass. And then because you're doing work against gravity, because if you drop it down, there's acceleration due to gravity, right? So then there's G, which stands for acceleration due to gravity, and the value of that G is 10 meters per second squared. Okay, that's a value for G, which we've used when we did forces, when we converted a mass to a weight or gravity force. So this is actually your gravity force. You're doing work against gravity. And in order to gain gravitational potential energy, you've got to lift it through some height. So the other thing that's involved is H. So if you go M, which is the mass, times 10 times height, you will get, you'll be able to calculate what is the gravitational potential energy gained if you're lifting it up, or what is the gravitational potential energy lost if it's falling down. So it could be either gravitational potential energy gained or lost. Okay, and then the unit will be in joules. The other form of energy, the formula that we need to know, and you'll be actually given these formulae in your tests, but I'm going to show you how to use them in this lesson. So the other one that you need to know is kinetic energy. You just need to know these two forms, right? Okay, for year 11. So kinetic energy, energy is represented by E, and for kinetic, you got the EK. Okay, now let's think, what is that formula? What's that going to look like? So first of all, let's reason out what do you think the kinetic energy may depend on. So the kinetic energy has to do with movement, and the movement has to do with speed, right? So, and the letter for speed is V. So there's V involved in the formula, but you can have, so things have to move, right? And everything's got mass. So the two things that are dependent on kinetic energy is the mass of the object and how fast is it moving. Now the formula is a bit different from what you've probably seen before. So it's half m, which is the mass, times v squared. That means it's speed squared. So if the mass was 10 kilograms and the speed was 2 meters per second, when we substitute and put this into our calculators or to calculate it, it's half times 10, which is the mass, and if the speed is 2, you go 2 times 2. Okay, so that's the meaning of v squared. And no matter what form of energy it is, whether it's kinetic or whether it's gravitational potential, the unit is always the same. The unit is always in joules. Okay, so we're just going to do one question from your booklets together, and I'll talk you through this. It's using these two formulae, all right, and it's based on a scene at our school. It's to do with the school library. The library is closed, like what's happening now, you know, and your books are due and you've got to return the books. Okay, so we're just going to show you where that question is. So in your booklets, and I put this in PDF form, so it's right at the start. So the first page has got some notes over here, and it's the next page which says energy calculations. So I'm just going to go through this. The library is closed, and so a student puts a book which has a mass of 500 grams through a slot. So I'm just going to write mass is 500 grams, which is 0.500 kilograms. So every time mass is given in grams, we need to put it into kilograms. And the slot is 1.3 meters above the floor. So your height is 1.3 meters. So there's, okay, this is actually there in our school. And so because the book shouldn't get spoiled, the book slides down a ramp, which is 2 meters long. Okay, so this is a scenario. So there's your book, there's your ramp, and this ramp is 2.1 meters long. This is 2.1 meters, and that height is 1.3 meters. Okay. Later on, the librarian picks up the books, carries it at a height of 0.80 meters across the room, and puts it on a shelf which is 2.3 meters high. So that's a scenario. In each of the following stages of the book's journey, use delta EP equals mg delta h. So the triangle is called delta. So this is where I'm reading from. Okay, to calculate the change in gravitational potential energy and state whether it's gained or lost. So when it slides down the ramp, okay, so when something is falling down, the energy, gravitational potential energy is lost. Okay, and the gravitational potential energy lost is mg delta h. Sorry, my dog's barking. Someone must be outside. Doesn't matter. Okay, so how do we substitute? So your mass is 0.500, g is 10, and now what are we going to use for the height? It's this vertical height, right? Okay, so we need to use times 1.3. Okay, so in your calculators, you go 0.500 times 10 times 1.3, and you get 6.5 joules. So the answer to that is 6.5 joules, 6.5 joules of gravitational potential energy is lost. Okay, then the librarian picks it up from the floor. When she picks the book up, she's lifting it up, so she's going to gain gravitational potential energy. How much does it gain? So this is B. This is also mgh, okay, delta h, and mass is still that much, g is still the same, but when she picks it up, she carries it at a height of 0.80 meters, so we're looking at that number, times 0.80. So what do we get? I think you get 4 joules, just off the top of my head. So 0.5 times 10 times 0.8, so you get 4 joules, yeah. Okay, so you just write it as 4.0 joules, two significant figures. As it is carried across the room, so when the librarian is just carrying it at that height across the room, there is no change in height, so and gravitational potential energy is not gained, neither is it lost. So for C, the answer is 0. Okay, now when she puts it on a shelf, so a gravitational potential energy is only gained or lost when there's a change in height. Okay, and so C is 0. D, when she puts it on the shelf, it's again mgh, and your mass is 0.500, your g is that much, and your height is 2.3 meters, and you multiply all this and you end up with an answer, and you get 5 times 2.3, and you get 11.5 joules. So the higher you lift, the higher you lift it up, the more gravitational potential energy it gains. So these are your 3 answers. For C was 0. These are your answers for the first part of that, and that is using the formula EP equals mgh, and I'll make a separate video for this next one, because otherwise the video will be too long and you will lose your concentration. So I hope you understood that. Bye for now.